In this section, I'll explain you how to convert the standard form to a vertex form. Since we will be working on a parabola and few lessons later we will graph the parabola, I would like to use the function. So I use the function f of x equals 3x squared plus 12x minus 12, and let's pretend I need to convert this. It's written in the standard form, and I need to convert this into the vertex form. So the vertex form is f of x equals a times x minus h squared and then plus k. Let's talk about the standard form really quick. When quadratic function written in standard form, what you can take from it, you can see that the first thing first, I will recall the standard form ax squared plus bx plus c. So what you can take from this, you can see that a equals 3, b is 12, and c is negative 12. When I need to convert into the vertex form, what do I see in the vertex form? First thing that I see, it's a. Step by step, how to start the conversion is to pull out that a, because you see that the a is sitting outside of parentheses, meaning it was pulled out from that trinomial. So let's do that first. So a, which is 3, I will pull it out, and then I see that I have two terms. And it's actually a perfect square, but the two terms inside of parentheses. So when I pulled out 3, I'm not going to do it from all 3 terms. I just need 2, because the third one, it's a freelancer, kind of, it's negative 12 as of right now, and then that's the k on the end, which is I call a freelancer. So that would be fine. I'm not going to touch it. So I will only pull out 3 from first 2 terms. So that will be x squared plus, and then if I pull out 3 from 12x, that will be 4x, and then minus 12. So now it somewhat start looking like the vertex formula I will need to end up with. However, I have more work to do, because in the vertex form I have a perfect square. In my case so far, I don't. I can use those 2 terms to complete the square, so that will look like a perfect square. So let's work on this. Remember how we were completing the square? If we have 2 terms, we need to come up with the third one. So the third term, and I have a separate video on that one, what you do, you take 4, divide in half, and then square, and that become your third term. And remember, it's always plus, it's always positive. So 4 divided by 2, 2. 2 squared is the 4. Now, we artificially added 4. It was never there, meaning I have to immediately subtract 4 to keep the value the same. So I'll do that. Parentheses completed. And then I also have minus 12 in the end. Equals. So the first 3 terms I will roll into the formula of a perfect square. So that would be x plus 2 squared. And again, if you have any questions on completing the square, just find the separate video that will explain you how to do that. And I have minus 4 and then minus 12. So now I need to distribute 3 inside of parentheses. So I'll have 3 times x plus 2 squared, then 3 times negative 4, minus 12, and then I have minus 12 equals. So minus 12 will give me minus 24. So that will be 3 times x plus 2 squared minus 24. So now f of x equals 3 times x plus 2 squared minus 24. And this is your vertex form. The reason I called vertex, because you can find the vertex easily from this form. But you need to do just one more step, because the vertex form has a different sign. Inside of parentheses, I have to have minus and I have plus. So as a k, is positive in the formula and mine is negative. So I need to rewrite using exact format for the vertex form. So 3 times x minus. The form says it has to be minus, so I'm gonna put minus, but I have plus 2. So what do I need to do? I need to put minus 2. Negative, negative will give you a positive, so we're good. And I also have plus in the vertex form, so I'll put plus like form set to. And then, but I have negative 24. So then minus 24. So I didn't change anything. I just rewrote into the vertex form with the right signs. So once again, minus minus, I have a plus, and then plus minus, I have a minus. So once again, I did not change anything. I just rewrote into the vertex form. So let's see, on the position of H, I have negative 2. In the position of K, I have negative 24. So the coordinates of the vertex will be negative 2, negative 24.